yesterday we were given formulas, we found terms, we talked about if it was converging or diverging. Today they're going to want you to write your own formulas, and so today's there's a lot more formulas, and we'll talk about, at some point what formulas you need to know for the test. But what would you say is the difference between these two sequences, and don't say the numbers are different?
That one's being cubed. It's like 3 times 3 is 9, 2 thirds is 9, 2 thirds is 27, 2 thirds is 81. It's not
On this one, if I said, what am I doing to get to each term, to the next term, would you agree that we are adding 2 each time? What would you say is happening on this one to get from each term? You're multiplying by 3? You agree with that?
Yeah, it's like.
So this is like times 3 times 3 times 3 times 3. Or you could say it's like 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, 3 to the fifth. Yes? These are the 2 types of sequences. This is called an arithmetic sequence, arithmetic, but we get to say arithmetic.
This is arithmetic and an A in it. Arithmetic.
I think it's arithmetic. Like that. Only we don't say arithmetic sequence, right? We say arithmetic sequence. It does sound very nice. So it's like an adjective now, right? Arithmetic sequence. So you can say arithmetic sequence if you want, but that's really not proper. This, we're multiplying, we call this a geometric sequence. Get it? Arithmetic, geometric. Geometric sequence. The important thing to know is the formulas are different if you're adding each time or if you're multiplying each time. So you have to make sure that when you're writing your formulas, you're using the right formula. If it's an arithmetic sequence, you use the arithmetic formula. If it's a geometric sequence, you use the geometric formula. And I saved you lots of time for writing because I printed them out for you, because in our rush to get to finals, I'm just done with waiting for you to write, and I'm just printing them for you every day. And
I like it why it's called geometric sequence.
Why?
First term's cubed.
Is that why?
It's the shape, get it, geometry, shapes.
That would work. But what if it was a 7 first? Oh, wait, no.
7 cubed. Pretty good at it.
I don't get it.
No, because 7 cubed is not
geometry and shapes.
And
cube is a shape. Get it was a joke. The word association.
It's a bad joke. So, an arithmetic sequence can be written in this form, and really you're just adding every time. So they say the first term is A, and then you add some number, A plus D, and then you add twice that number. So if you think about the one we just said, if this was 2, this was 4, this was 6, if you agree, you add 2, and then it's like you're adding 4 to the original number, and then 6 to the original number.
Yes.
Not really a big deal that you have to know where that comes from, but basically for the nth term, you can think about this would be what you would get, right? So if you wanted the 7th term, you would take the first number plus 1 less than the term you're at times whatever you're doing every time. We call D the common difference. It's just what you are adding or subtracting, right? Because you could be subtracting a number each time. And if you want to write the formula, there are 2 ways you can write it. You can write it as an explicit formula, meaning that you could plug any number in there. I kind of like those better. So if you want to write the nth term for an arithmetic sequence, it's always going to be just this. It's going to be the first term plus n minus 1 times the common difference. And so what they're going to do today is they're going to give you some formulas or some sequences, and they're going to ask you to write the formula. You can write the exact same sequence as a recursively defined sequence, and it's just one of those things that you just have to learn what to put in there. And again, we could write this multiple ways, but we're going to stick with the A sub n, so it'll always be the same. And remember, recursive means that you use the one before it. So in this case, my 2, 4, 6, it means you would take the one before it and add 2 to it, right? That would be what we were doing. That would be the common difference. But we're going to say A sub n equals take the 1 before it, so that would be A sub n minus 1, and you're going to add whatever your common difference is. And every every time. That's it. There's nothing else to do with it, except you need to say where to start. And they were using K and they were using other numbers. Since we're using N, we're going to say we're going to always start with N greater than or equal to 2, because they're going to give you the first term, and then we'll write the formula for every term after the first term. These are formulas you need. Or maybe you're right on the formula sheet. To be honest, I'm not a big fan of this whole stuff. So, like binomial theorem, that's fun. Probability, okay. The end of this chapter, proof by induction, I can do that. Sequences and series, blah, who cares? It's just patterns, right? I'm not a big fan of it. Which is why, just to let the cat out of the bag, I'm going to let you have a formula sheet before the test that you can write this down. That an arithmetic sequence formula is this, and you just have to plug it in. So, it's not that bad once you get to it. I didn't pay attention. What was it?
It was like 2 girls in like swimsuits facing like with their backs facing things, but then it was like a cat photobombing like in front of it covering their butt.
I'm so bad at dress code things because I don't pay attention.
It was so funny.
Thanks for the soda.
You didn't get caught.
Cause yeah, cause he always pick up on me.
What did you have? Like,
I get caught. It says when
All right, so this is what's on your homework. Same directions, parts A through D, but it's not really that bad to do. It's just practicing writing the formula and using the formula. For the arithmetic sequence, find A, the common difference, B, the 10th term, C, a recursive rule for the nth term, and D, an explicit rule for the nth term. It's like four problems in one. A is really not bad to do. The common difference. What are you doing to get to each term? We're adding 5. So you could just write 5 there. I'm just gonna say D equals 5. Might want to be on the right page. I'm gonna skip part B for now because I'm gonna wait till I have my formula. Could we just keep adding 5 till we get to the 10th term? Yes. But part C and part D, we have to write a formula. So I'm gonna leave a space for part B. And I'm gonna come back. Part C, a recursive rule for the nth term. Recursive one, it's kind of annoying, but again, if you have the formula written down, you're just going to say that the nth term is taking the 1 before it, so a sub n minus 1, and adding the common difference. Then you need to say when n is greater than or equal to 2. Because they give you, like, they'll have to give you the first term, I guess. Okay. We should really just say, oh, right now we're racing. Oh, no, you can't.
That was kind of sketchy.
It kind of not sad. It was like
With the ominous background.
and it had like a full wingspan extension from this one. It's actually terrifying. I've got like 15 minutes to go.
I'm going to cover my window and wrapping it. So, what we really should say when we do the recursive term is we're supposed to give the first term, right? In a recursive sequence, they tell you the first term. So, a sub 1 equals negative 4, and then I'm going to say for every term after that, take the 1 before it and add the common difference.
So there's no n straight equal to 2.
And then we say n is greater than or equal to 2. Why do you have to say that? Because you can't get this for the first term. You can't say the first term, I'm going to take the 0 term plus 5. You can't do it for n equals 1. That's why they tell you to start with 2. You don't have to think about it. It's the same every time. And I'm going to let you write a formula sheet and put that on your formula sheet. And all you have to do is replace this for D, and that's it. Like, that's the answer every time. So don't overthink it. It's just a fly.
I thought.
Not if it.
Well,
The explicit formula says take the first term plus n minus 1 times the common difference. And you just have to plug those values in. We're not plugging in a number for n right now. We're trying to write the formula. Leave n in it. But you should be able to plug in a, you should be able to plug in b, and I do want you to simplify that. But you're going to be able to combine some like terms here, right? So the first term is a, which is negative 4, plus n minus 1 times b, which is 5. And just work it out. FOIL it, combine like terms, and give me a nice formula for the nth term of this sequence. Not FOIL it. Distribute. What I meant to say. 5n, and I'm going to just do this in my head. Let me know if you need more words than this. 5 times negative 1 is negative 5, plus negative 4 is negative 5. Do you agree with that? So this is my explicit formula, which is part B. I skipped part B because to me it makes sense. If they want me to find a 10th term, is it going to be much easier to find the 10th term now that I have this formula?
You just put 10 in for n.
It just put 10 in for n.
10.
So I can say that the 10th term is 5 times 10 minus 9, or 50 minus 9 is 41. See, this is just not, to me, this is not fun math. He's giving out toys at Toys for Tots. He came in this morning, and he got some homework questions answered. His eye's really swollen, and he doesn't know why. It looks like he got punched in the face, but he says he just woke up like that. And I said maybe someone came to his house and punched him in the face in the middle of the night, and he said, good thing I was sleeping. But he said he was the first person to watch my video, and I said you're probably the only person to watch the video. But that's and he said, why should I ever come to class when I can just watch the video and print the notes out? And I was like, that's what I'm saying.
So you're encouraging him to skip school?
That's what I'm saying.
I'm just saying, you should appreciate that I record for you, that you can skip a hard math class and still
I
go
never
home.
can hear the volume. Like I try, like I get the notes, but I can't put in like a video for it. So I can like see it, so it's popping down. Like I teach myself.
Are your speakers plugged?
I watch it on my yeah.
You do this one.
I watched on my phone.
Actually, I'll do part 1. What is D on this one?
3.
Positive 3. So you do the rest. Ready, go. On the recursive one, make sure you put the first term, right? So like you really should say a1 equals negative 5. Then you can say a sub n equals a sub n minus 1 plus 3, which just says add 3 to get the next one. N is greater than or equal to 2. And again, it's just one of those things that you just have to remember that. It's easy to forget that part, but hopefully if I let you write a formula sheet, you can put that in your formula sheet and it's easy to remember. This one, recursive people get weirded out by it, but it's actually like there's no work to do. Like you don't have to do anything to simplify. But for the explicit one, I do want you to simplify that and say the first term plus n minus 1 times the common difference, which is 3, So that would be 3n minus 8. And then that's what I'm going to use to find my 10th term, which would be 10 times 3, which would be 30 minus 8, or 22. Probably on your test. Very similar question, parts A through D, asking you to find those things. And then the other type of formula, or the other type of sequence, which is a geometric sequence, we can also look at the formula for it, for the nth term, for the explicit and the recursive formulas. But we're multiplying instead of adding, so it is a different formula. It's a really short notes. I don't even know why I printed them out for you. But. So geometric sequence, if you are multiplying by the same thing every time, instead of adding something, we're multiplying. So notice they use R instead of D, because you're multiplying by a common ratio. So again, A is your first term, and then the second term would be A times R, and then A times R squared. And again, think about that first one I wrote out for you. Right, so like 3 is your first term, and then R in this case would also be 3, because you could say 3 times 3, and then 3 times 3 squared. And again, notice that for any nth term, the power that you're multiplying by is 1 less than the term you're on. So that n minus 1 comes up there, but it's an exponent now because we're multiplying each time instead of adding. And instead of talking about a common difference, we talk about a common ratio. And that's what you are multiplying or dividing by. But be really careful, because if you're dividing by 3 each time, what would R be if you were dividing by 3 each time? 1/3, right? You have to write it as a fraction. Good guess. These formulas, again, not a whole lot to simplify on because we're multiplying, but explicitly defined, we're just going to take the first term times R to the n minus 1. And unlike the arithmetic one, you can't simplify this. You can't multiply A times R because it has a power up here. So you just leave that as your formula. And recursively defined, again, you're not going to have to simplify, but you do need to state the first term. And then you're going to say that every term after that, you're going to take the one before it, A sub n minus 1, times R. For every n greater than or equal to 2. And again, if I let you write the formulas out on a formula sheet, then it's just plugging in the numbers, right? How could I be any nicer? Same thing, only now it's geometric, and it says find the common ratio, find the 8th term, find the recursive rule, find the explicit rule. Again, I'm going to skip part B until the end. But what would I be doing each time in this problem? We're multiplying by 3, so that means R is 3. So the recursive rule says I need to say the first term is 2, and then every term after that, so A sub n, is just going to be A sub n minus 1 times that common ratio, which is 3, for n greater than or equal to 2. So I'm going to take the one before it and multiply by 3. I like the other formula better because I can just plug in the numbers, but for the nth term explicitly defined, I'm just going to take A times, or why would I say A? The first term, which is 2, times 3, which is the common difference, to the n minus 1 power. Right. You cannot multiply this because we don't know what that exponent is, so that does not equal 6 to the n minus 1. Questions on where I'm getting that? Just plugging in my n, or my A and my R in those formulas. And then go back to do the 8th term. I can now say that's just 2 times 3 to the 8 minus 1 would be 3 to the 7th. I'll just let someone tell me that. Oh, I think I have it written down, maybe. 4,374. I didn't actually do it. You didn't say it. Questions about that? What about the second one here? What would R be in this one? And that's exactly
I'm not a big fan of R in this one.
It's negative 1. Stupid. That's the best to say.
I didn't know it was I don't know why. So stupid.
Brady said stupid. I don't like the word stupid. It's not a proper. It's not an appropriate word in my house.
Well, which was rude. Is not flattering, okay? It's not agreeable.
Who wants to use recursive sequences? Aren't they just ridiculous? Ridiculous. That's what you can say instead of stupid. When I used to say don't, I think I might have told you this already, but I used to say don't be stupid a lot, like before I started teaching. I'm like, don't be stupid. But then as a teacher, I was student teaching, and I almost said don't be stupid, and then I was like, oh, I probably shouldn't call students stupid, but I wasn't really meaning stupid. So I was like, don't be silly, and so then I started saying silly all the time instead of stupid, but it really meant stupid. That's my stupid.
I figured it was because you had kids, so now you know when you call it
Now you
silly.
know when I say silly.
Like, oh, Parker, you're so silly. She says silly, Parker, she means stupid.
I know, mean stupid. But I used to. When I first started teaching, that was a long time ago. I'm old now, remember?
You're like 30.
2.
Oh my gosh.
Probably.
Not quite.
This one's not that hard to find the 8th term, because it seems to me like all the even terms are positive and the odd terms are negative. But I think it should be, if you wanted to figure it out with the formula, you could say negative 2 times negative 1 to the 7th, which would be negative 1 times negative 2, which would be 2.
That's not fun. Why is that my calculator?
I have to say it hurts my soul every time someone does negative 1 or 1 to anything on their
No, I
calculator.
just forgot that it was like let's see. I just saw the 20 thing. I forgot. You just automatically plug it.
You just automatically plug it in. This is 9-4 day 2. Not a huge amount of problems, but there are some that have the parts A through D on them, so, maybe take a little bit of time. Maybe a calculator is not such a bad idea to have on some of these. But don't forget, if you're dividing each time, you're going to write that as a fraction. So if you're dividing by 3, that your R is 1/3. But that's it. There you go. 9-5 is all about adding up sequences and adding up infinite sequences. And then 9-6 is proof by induction, which is super exciting. And then that's it. That's the whole chapter. So you're almost done with first semester calculus. Don't forget that retest. Tomorrow is the last day to retake your chapter 3 test. So if you are planning to retake either part of that, today, tomorrow, after school, before school, during school, I don't care, but tomorrow, make sure that you have planned to do that. And test corrections are tomorrow as well, even if you don't plan.
Just retake one part.
You just retake 1 part. So you're logging both sides? Taking log 2 on this side. You're dividing by log 1/3.
Oh no.
Oh my gosh, I'm still